Hello and welcome back to the Langchain and Gemini series. This is the part 3 of the series that we've started. In parts 1 and 2, we've covered what Langchain and Gemini are. We've moved on and set up the environment, understood how the YML files are loaded, created, stored. Then we've imported our environment, set up the environment, imported libraries, loaded our model, that's Gemini Pro, seen how the prompts are generated, how the chat prompt template is used, how templates are created, how chains are invoked. We've seen what Langchain expression language is and how we are using it. That's to use or make things more dynamic. In the second part, we saw how to handle multiple topics, how to get responses to those multiple topics, and see what are other components of this responses variable. We saw the metadata, saw the safety ratings, delved into AI ethics, and understood about tokens. Now we will move to the third part of the series where we'll delve into conversational chain without memory. So that's something we've already seen. But let me build up and set up the grounds for the conversation chain with memory. So let's start with our basic prompt. We'll say that our basic prompt is built using the chat prompt template, chat prompt template dot prompt underscore template. This we've already done earlier, wherein we said, tell me a fun fact about, but this time let's keep it simpler. Let's say we just specify the entire input in these quotes itself, and I'll call the placeholder. This user input is the placeholder for now, and I'll call it user input. The variable, the argument here is template. Let's build our basic chain. The basic chain would be similar to the earlier chain we built, and we've also called it our pipeline. So basic prompt, and this basic prompt will get inside or go inside the model and fetch us a basic response. Let me call this response number 1. And this basic response 1 would be when we invoke the chain. So basic underscore chain dot invoke. We want to invoke a response about the user input. Let me ask the question, who was the first president of India? Let's run this and fetch the basic response 1 dot content. Dr. Rajendra Prasad. Okay, we've had our first response. Let's also see if the model knows what we asked earlier. Let's see if it has memory of the question that we just asked. So I'll call a basic response to, I'll call the same chain, basic chain, invoke, and this time user input will be who was the second. Now, if I write who was the second president of India, that in itself is a complete command. That itself is a statement that the model will be able to answer independent of the first question. So that's why I'm purposefully restricting my question to who was the second, so that if I ask you who is the first president of India and you give me Dr. Rajendra Prasad, and then I say who is the second, then you'll obviously understand that we are talking about the president here. But let's see if in our current state, can the model understand that we are still asking about the president of India. So basic response to dot content. Let's load. This context does not mention anything about who was second. So in short, the model does not have memory of this first part of the question. It doesn't understand or doesn't remember that hey, we earlier asked a question about the first president. That's why it can't answer you about the second. Let's see what and how we introduce memory into this entire framework. With memory, we will be able to retrieve questions, conversations from the past. Now that we've written our code to import these libraries, let's see what each of these does. So langchain.memory, from in the first line, we say langchain memory, import conversation buffer memory. This is to store a certain number of past conversations. We'll see how many conversations we want to store. Then the second line of code is to hold the historical conversations we have with Gemini. And the third line of code is to just use the runnable parameters, which we'll see now. So I'll start by initiating my memory variable. This memory variable, we'll use the conversational buffer window here. So conversational buffer window memory. We'll say return underscore messages is equal to true. We want the model to return messages. And let's set up the conversational history to 2. This k is the parameter for that. It holds the last k conversations in memory. Advanced prompt is equal to chat prompt template. This is similar to what we've done earlier. Chat prompt template. Now we'll use another method, which is from messages. Let's open the brackets and initiate a square bracket here and get inside the square bracket. So let's remove the messages. Okay. Now inside this, we say how the model or how we want Gemini to behave. So we'll say system. It's either system, user, or assistant. You can look up the difference between the three. So let me say that you are a helpful AI bot. That's how I want the model to behave. That's how I want Gemini to behave. Then I'll call the messages placeholder, the library that we imported in the second line of code in the of the previous cell. Messages placeholder, bracket open, it accepts an argument called variable underscore name. This variable underscore name would be, let's say I call the variable conversation log. Conversation log, and the third input would be whatever we want to give the user input as. So let's erase this part. And we have the third input as the user input. Let's say it's just input for simplicity. Although earlier we've used user input here, but now let's use just input. Let's close up the brackets. The brackets are, the first one is this. So we've closed this. Second one is here, we close that. Third one is here, we close it. Fourth is closed. I think this doesn't belong anywhere. And let me run this code. So in summary, we're asking Gemini to behave in a certain way, asking it to take into account any conversational history we have, that's here. And then we are adding another question on top of whatever history Gemini already has. I'll also show you what the memory currently holds. So memory dot load memory variables. You'll see that the history currently is blank. So right now the model does not have any conversational history. Let's add things to this history, and I'll use from operator import item getter. Let me build the advanced pipeline. Let's call it ADV chain advanced. Open the brackets, and then we say runnable pass through dot assign conversation log is equal to runnable lambda memory load variables, and then we say item getter history. Okay, so I think that's a very good refill that we've received. So I'll tell you what's happening here. Let's break it down a bit. Advanced prompt, model, and okay, so let's see it from the top. As earlier, we've defined a chain. So you remember this is a chain. Was our basic chain, and we just said this is the prompt. This prompt will, through this pipe separator, it will flow into the model. Now it's a bit complex, but it is mostly the same. So you remember there was a first part, then this first part was absent in the previous code, in the basic code. But if you ignore this first part, so if you ignore this much part, then your chain is same as it was before. Your prompt was going into the model. Now we're giving it another section, and this section would hold your history. That's why your history, along with your prompt, would flow into the model and fetch a response for you. So that's the only addition we've done on top of it. The conversation log is equal to runnable lambda memory, load memory variables. So this code we've already executed before. For now, the history is blank, but this is the part where you can, or which helps you to load memory data from the memory variable. Our history is loaded, our prompt is here, and then the model is here. So what happens at runtime is that we load the historical conversations that we have with Gemini and store it in the history variable here. Then item getter history. So item getter history, this part will access those conversations from the history variable, right? And then along with the historical conversations, we'll be sending the prompt to the model to get a response. That's the summary of it. I'll run this and move on to the next line. Let's define our user inputs again. User input one would be, again, we'll call it the same way as we did earlier. Our placeholder was input. So let's use the word input again. And let's say, who was the first president of India? This is the same question that we've asked in the without memory section. Who was the first president of India? Let's ask it again. Response would be stored in ADV response one because I'll be using multiple inputs here. So I'm starting off by segregating it by 1, 2, and 3, so on. So input is here, response is here, and let's see what's there in response.content. We've encountered an error saying that invalid argument 400 developer instruction not enabled for models, and the model name is Gemini Pro. So you remember we're using the same model from the past 3 lessons. That was Gemini Pro. I think it's asking us to change this. So I went over and looked up the internet what model we should be using. And this is the one that they've suggested. Let's see if this actually works. Let me copy it and take it down, take the code down below. This is where we're using the model. Let's add another code and say the model is now not Gemini Pro, but Gemini 1.5 Pro latest. Let's run this Gemini Pro model. The model has run, and let's see if we can generate a response out of it. So it's working on the second cell. You can see by this small green arrow here. Now our model is able to generate a response, and we can see that this Rajendra Prasad was the first president is served from this. Right. So we've added this. We've seen how the first input or what response the first input generates. Now, as promised, we'll help the model store this memory and then input or receive further questions and answer those questions based on this memory plus any new questions. Let's call the second, or let's see what the memory load variables looks right now. So memory dot load memory variables. As we saw earlier, this is the line that I just executed again. Down here, we see that the history is still blank. So this is because we haven't updated the memory. So this is before saving. Let's do another line of code which will save the conversation to memory. So I'll call it after. And in between this, let's save this conversation. So into the memory variable, memory dot save underscore context underscore save context. So what do we want to save? We want to save the input as well as the output. Let's not hard code it, but let's put in the user input variable here. So that's our input. And what is your output? The output, again, you have to initiate a dictionary, close this one, open this. Okay, so our output is an EDV response one dot content. the closing parenthesis. Okay, we need a curly bracket here, and we've received another error. Let's see. The way we resolve it is, I think it just accepts the input in the before the comma and then output in this fashion. Let's see what happened to the memory variable after we saved the conversation to memory. So we've added one part, that's message. That's our question, human message, and the AI message, that was the answer. Both of these are stored in the history now, in the memory now. Let's ask another question. Let's say, let's ask the same question. So earlier, if you remember, we asked it, who was the first president? And then we just said, who was the second? Let's do the same thing. I'll copy this entire thing and invoke a question. So let's call it, before this, let me define user underscore input underscore two as our second variable and say who was the second. Model should realize that we're asking about the second president in continuation with the first question. Advanced response content, and let's see what the answer is. So the model was able to recognize that this is in continuation of the first question. Now we'll again, don't forget to save everything to memory. So I'll use this code again to save things to memory. Save context, my user input to, and advanced response to dot content. Let's see if our memory variable is updated. I'll use the code and paste it here. And now you can see the first message is here. Who was the first president? The answer to the first president. The second message is here. Who was the second, and the answer to the second president. We've restricted our arguments, number of arguments, to n is equal to 2 here. So you remember earlier we were using the variable k here. I went through the documentation and saw that it would be better to use n. That's why we were seeing the warning earlier. Now we are using n. So n is the number of conversations that it holds in the memory. For now, you can see two conversations. So this is a conversation, human AI. Then this is another conversation, human AI. Let's see if it actually holds three or not. So let's invoke another section, and let me say user underscore input underscore three is equal to curly braces open. Who was the third? Let's see if we are able to generate a response. The model does understand, or it has all this conversation in its mind. So it knows that just looking at this response, you can decode that the human must have asked a question about who is the first president of India. Then add on top of that the second response, and then you'll be more certain that we are talking about the presidents of India. And this was the first one, this was the second one. So if the model asks us, or if the user asks us who is the third, then he'll be able to decipher that the third one would be, we're talking about the presidents, and this is the third president of India. Let's add this to the memory. Let me say, add this third user input as well as the output and see what our memory looks like. Now you see that we have three responses stored in the memory. This is the first one, this is the second conversation, and this is the third conversation. Now, when we ask a question to the model, it will, since we've restricted the number of conversations to two here, the last two conversations, the model won't be taking the first, or this conversation into its memory. So although it has stored it in the memory, but while answering your next question, the only memory history that your model will have would be these lines and not the first president of India as well as the answer to it. Now, I think even without having the first question and answer, your model will be able to answer the fourth. I mean, if I ask it who was the fourth, then the model would understand that the previous two questions were about the president. That's why this is the answer. Now it would automatically, I think it's smart enough to understand that the fourth, if I say who is the fourth, then it will be able to understand that we are still talking about the presidents of India. So user input four, let's call it who was the fourth, advanced response, store it in content, and let's see the answer. It has rightfully understood that it's the presidents of India that we're talking about, and that's how it was able to generate a response. But let me remind you again that we still in the fourth message, in the fourth question, we did not take into account this part. We did not take into account this question, first president of India, and the first answer to that question. So just on the basis of these two, the model was able to answer the question fourth. And remember to save this to memory like we just did above, and then you can see what the memory looks like. So congratulations on building a chain with a memory in which your model would know the stream of events, and it would remember as much as you wanted to, and it would take into account as much as you would want. So you can make this variable 20, 200, 2000, although that would take longer times to run and process, but you would be able to generate responses based on the last n conversations. I hope you enjoyed this tutorial, and I'll see you in the next one.